So good morning, good afternoon, everyone, and thank you very much for participating in these webinars about probability of default. For everyone that had not participated in the previous episodes, let me give you some background. Starting this year, I decided to write a book about probability of default. What drove me about that was the fact that I started perceiving that the pandemic didn't really teach us the lessons that we should have learned after that black swan that paralyzed the whole world. And actually, with this background, I started thinking what's going on in the world. We are not prepared for getting back to normal after the pandemic. Everything that is happening today, except the war, were anticipated as soon as the pandemic started. And we can say, unfortunately, that we kind of forgot about the effects of the pandemic. So that was one of the motivations. And the second motivation is that we have been invaded by the changes brought by technology to the point that we are forgetting the essential. We are forgetting that things have a raison d'etre, a cause, something that explains clearly why everything works. And nothing is more evident than the way as people approach managing credit risk. And in general, it's not only managing credit risk. Those who attended our previous webinars could see that when we talk about default, we are talking in general about broken promises. So it not only applies to credit decisions, it's also applied to any decision you can make in life when you rely on trust to other people. Default at the end of the day is broken promises. And this is one of the things that we need to learn how to work. So in this episode, I hope you are going to enjoy as much as I've been enjoying the process, but what I want to bring you is through the journey that I have been following in connection with this process. And this journey has been basically oriented to taking into consideration that one of the things that happened to us is that ideas get stuck to us. And I read a recent book that said something very interesting. A preacher, a prosecutor, and a politician is coming into your brain. When we have ideas, we tend to stick to that ideas, and we put some faith. That's the preacher side. We tend to derogate and minimize people who does not share the ideas with us, and that's what we are as prosecutors. And we try to sell our opinions and our ideas to the rest of the people. That's where we act as politicians. And that kind of approach is creating a lot of trouble because we are certainly forgetting that things have a reason to exist and that they come from years and years and years of experience, learning processes, and so on. So the approach that I decided to take, which is exactly what this journey is all about, is going through, first of all, landing into the concept, was our first webinar, then understanding what default is all about. And we are today starting or keeping on analyzing and understanding the probability theory, the science of probability, because that should drive to our next step, which is defining our risk appetite framework, what kind of risk we are ready to take and what kind of risk we don't want to take. And that goes into the inclusion in that analysis of an aspect of risk that has been neglected, which is the analysis of character. And based on what we learned, then go into the approaches of how the probability of default has been approached in the past by several institutions. And here I want to make a stop, just recounting that one of the things that we do in our consulting work is undertaking due diligence of companies that are in the financial sector. And when we ask them, how do you manage your credit risk? The most common response is, oh, what I do is I follow the parameters of the regulator, being the National Banking Commission in the case of Mexico, the superintendencias in the case of many countries in South America, or the central bank in other countries around the world. But when I ask them as a follow-up question, okay, do you understand what the regulations mean? And they say, we don't care, because we just abide to the regulations. And that's where I come back very sad and say they should understand whether or not they are making a mistake or they are buying something that they shouldn't buy. Some others mention, oh, don't worry, I basically rely on a model that I bought from Moody's or Standard & Poor's. And the question is the same. Okay, very good. They have good names. And we are going to analyze further on in a further episode how Moody's and Standard & Poor's and Fitch Ratings and other credit rating agencies have been approaching the issue of probability of default. And we'll see the merits of that. I mean, we don't want to rely on being preachers, prosecutors, and politicians trying to sell and consider that everything that Moody's says is the word of God. And certainly we should be able to have good grounds to challenge that. So based upon what we have learned, and we also analyze how the regulators have been approaching the issue of probability of default. And at the end, we will work together into creating a model for credit scoring, which we call the Lambda score. That will come in probably the final episode. Now, if you want to see all the picture faster, well, you can simply go and buy the book. It's available in Amazon.com. Has two formats. One format is downloading to your Kindle or to your Kindle application in your smartphone. You don't need to have a Kindle to read a book in the Kindle application. You can use the application in any of smartphones. And the other thing that you can do is going into Amazon and order the hard copy if you want to keep a hard copy there. But if you don't want to do that, then you can do is follow these webinars. And in these webinars also, I will give at the end of the day today the link to YouTube. In my YouTube channel, you have all the recordings of these conferences. So this is something that we keep on a permanent basis.
They can engage any.
Sorry. Okay. So what is important this episode of today? Well, it's important for everyone. If you are in the business of financing, the episode of today will help you understand where the foundations of probability of default come from and avoid the shame of believing without understanding. If you are in any other business where your sales proceeds come from extended credit terms to your clients, it also will provide you some good material, because among other things, what happens is that the accounting standards have created the need to understand and apply a concept of probability of default, even if you are not in the financial business. So if you sell any kind of product or service and you have account receivables, you will need to estimate your current expected credit losses. For all these businesses that are subject to the International Financial Reporting Standards, that is basically most of Western Europe, Asia Pacific, Latin America, and except the common law countries, all the rest must apply the concept of IFRS 9, which started to be enforced in 2018. If your business is in the United States, the regulation or the accounting standard is SAU 2016-13, that's topic 326, that becomes effective on January 1st, 2023. And again, that requires the application of a current expected credit loss. In addition to that, if you're a financial institution, then you are subject to the provisions of Basel II, Basel III, and now Basel IV, that demand for financial institutions, they need to have a very scientific approach of the way they estimate their expected losses. And expected losses are the result of multiplying the probability of default times the loss given default times what the amounts that are exposed at default. So this is the importance of today's episode, and I hope that you are going to enjoy I apologize. I put myself in mute. So now I need to mute my other co-host. Here we go. So getting into the concept of probability of default, the question is, how do I know that the person who owes me money is going to pay me back? It's as simple as that. And that goes into the next question, which is, how do I estimate that that person has the willingness to pay me? And we are going to go further on that. That has a lot to do with character. And the second question is, how do I estimate the probability that he, she, or it, if it's a corporation, for example, can pay me, has the ability to pay me? And that is going to go into the subject of capacity that we are going to analyze. And at the end of the day, this is important to take into consideration, is that this is showing me a distance between where we are today, when I am depositing trust in that person, and where are going to be in the future. And this is basically the key concept that certainly drives the subject of today. And it becomes very, very exciting, because one of the things that we learn is that the legacy of the concepts that fed probability comes from the, if you want to call it, the vice or the custom of people to gamble, to play games. And I think that the first starting point, I quote Peter Bernstein. Peter Bernstein is the former, late, of course, he already passed away, but he was a very interesting person. He was the chairman of Mercer Consulting, which was part of the group of Marsh & McLennan's and Johnson & Higgins, probably one of the best known insurance groups around the world. Peter Bernstein wrote a very interesting book that was called Against the Gods, the amazing story of risk. And in his narration, that I took that as a main source of information, he actually highlights the fact that the Greeks were the first ones that isolated from the concept that everything that happened in the future was the design of God. I mean, whatever happens is because God wanted that to happen to you, not because that was the result of a free decision and probably the outcome of luck. And that concept went into the point that everything that happens in the future is something that is only one of all possible events that could have happened in that future. And that's a very important point, because that goes into, okay, so if I'm here, and I'm going to leave you some sad story that I read this morning, an individual who came in the morning to see the sun rise in front of his house. He was drinking his coffee, and then the roof came out and it killed him. He, of course, could not foresee that that would happen. And well, eventually he could foresee that. And this is one of the probabilities or one of the possible events that could happen in the future. So how do we know that, and how can we measure that? In our past episode, we visited Fibonacci, and the main legacy of Fibonacci is that it gave us the concept of an easy way of using numbers in order to measure what is going to happen in the future. And the combination of numbers and games is exactly what take us to the probability science. We'll see exactly why. Well, when we get into the analysis of the science of probability, everyone coincides to say the starting point of probability theory is the Pascal triangle. And this is the Pascal triangle, and we are going to try to understand how we can get into the Pascal triangle in the future. And here's the story of how we got there. We highlighted the Chevalier de Méret. Chevalier de Méret was a gambler who actually had the puzzle. He wanted to learn what would be the fair way to distribute what was called the problem of the points. But the problem of the point was something that was raised in the past, around 2 centuries before that, by Fra Luca Pacioli. And before getting into the Chevalier de Méret, an individual called Gerolamo Cardano has introduced a lot of interesting elements that help to us to understand a little bit how Pascal got the famous Pascal triangle and how today's probabilities are based on these interesting discoveries. So if we get into Fra Luca Pacioli, a very interesting gentleman, Fra Luca Pacioli actually asked a question in his book that was called the Summa Arithmetica in Theologia. And what he asked was, A and B, 2 people, are playing a fair game of Bala. When they mention about a fair game, is a game that is not marked by the tendency of one of them to cheat to the other. So it is fair. And they agree to continue until one has won 6 rounds. But it happens that the game stops when one of them has won 5 and the other one has won 3. And the question that he asked is, how should the stakes be divided? Seems to be a simple question. But the point is not that easy, because the resolution of how to divide the stakes is not about what happened in the past, is what should have happened in the future. And that is exactly what created this puzzle. The solution that Fra Luca Pacioli gave to the problem of the points was not satisfactory to anyone. And the interesting part is how people went, after several centuries, to solve or to answer in a right way the problem of the points is a very interesting story. So let's talk a little bit about Pacioli, because it's very interesting. Pacioli was born, you can see, 45 years before the discovery of America. He was born in San Sepolcro, Italy, and I'll say Italy at that point of time was receiving a lot of the influence of the cultures of the past, the Greeks and the Romans. But there were happening many interesting changes. And one of the main change is that we are talking about the original of the Renaissance. The conception of the world around God have changed to the conception of the world around the man, the humanity. And I apologize if I don't mention woman right now, but at these times we were talking about the human being as man. So it was basically switching from the theocentric conception of society to the homocentric conception of society. And the way they did that is that Renaissance meant that they rescue a lot of knowledge that came in the past that was not really gathered. And one of the main reasons why it was not gathered is that because they lacked something that came in the Renaissance, that was the invention of the printing press by Gutenberg, that allowed knowledge to be extended. But one of the most important changes, and I put this this painting from Piero della Francesca, who was a very close friend of Pacioli, is because it really struck me the way as the paint is painted. I don't know if you see how deep the wall is behind the Virgin. The other thing that is interesting is that egg, which is the symbol of fertility, is hanging, but no one is paying attention to that. Everyone is looking horizontally. They are not paying attention to what is on the sky, what is on heaven. So it is an interesting point. And you can see that baby Jesus is floating. Interestingly, that came just at the same time with the dome in Florence was being built, when Brunelleschi introduced the concept of perspective to art. And that's interesting because when you have perspective, then you have a different view of things. Things are not flat. Things have the possibility to project in the future. So basically, what that created in terms of the mindset of Pacioli is that it gave Pacioli an important influence that added another one that is very important. In his infancy, Pacioli was educated in the Abacu education system. At that moment, children, and you can see that Pacioli was from a rich family, children could be educated in either the Latin school or the Abacu school. The Abacu school, for those who attended our last webinar, was the legacy of what Fibonacci brought to Western civilization. And the merchants wanted their children to learn the Fibonacci science because that was the best way to do calculations, to keep their business afloat. Now, Pacioli is very well known because Pacioli is the precursor of modern accounting. He actually, in the Summa Aritmetica, Geometria, and Proporzioni and Proporzionalità, he introduced the concept of double entry in accounting, which is the basis of what accounting is today. And his rationale was very simple. Every time you have an outflow in your business, there is an inflow coming. You are exchanging money for goods. You are exchanging money for services. Something goes out, something comes in. And that was the double entry in accounting that created what modern accounting is all today. So now it comes the other part of the story. We like games. We love games. I mean, if we go back to our personal history, I think that before the internet launched, the games like the Fortnite, which is one of the big hits today. I don't know how many games you play in your phone. I played many of them. But I used to play a lot with my friends, card games, and I still enjoy very much doing that. And also the dice. And when we go back to history, the history of games is really amazing. I mean, I just learned, for example, a week ago that in the chess game, the queen moved like the bishop in the past until the 15th century, when Isabella Católica became the most powerful queen in the earth. And at that moment, the chess the queen in the chess started moving in all directions. It was just the reflection of how life drives games and vice versa. So you can see in my book, I devote some time to the story of games from the ancient times, and it's really outstanding. Now, once we get into the games and we want to fall into the story of the Chevalier de Marais, we need to go a little bit further to bring some other guests that are going to explain to us certain basic concepts. And that brings us to a very interesting story. There is a gentleman, which I think is a professor of Columbia University, Stephen Strogatz, who wrote a book about calculus. And he gave a very interesting conference that is available in YouTube or TED, one of these, telling the story of the gentleman to the left. The gentleman to the left, or to the right of the picture, is a gentleman called Hermann Wouk. Hermann Wouk dedicated his life to write a novel, a historical novel, about the Second World War. And probably you have, well, he wrote several of them. One of them was brought into a TV series several years ago called Winds of War. A very, very interesting story about the Second World War. When he was doing the research to try to understand how the atomic bomb ended up in Hiroshima and Nagasaki, by the way, 70 years ago, exactly today, the concept, I'm sorry, 75 years ago, the concept of the atomic bomb took him to the Manhattan Project, and the Manhattan Project took him to Caltech, the California Technical University, where he met the individual who is in the right or the left of the picture, which was Richard Feynman, Professor Richard Feynman. So he got a very exciting interview to Richard Feynman, and Richard Feynman, when he finished the interview, asked him, "Did you learn calculus at any time?" And Wouk said, amazingly, well, no. And I think that a lot of us can say the same. It was a boring subject in high school and in the university, if you have the chance. And he said, you should do that because calculus is the language that God talks. And then the interesting part of the story is that Hermann Wouk decided to go back and take some calculus lessons. And he discovered actually that it was an amazing discipline. And it's amazing and interesting because the purpose of calculus is to calculate movement, to calculate change. So when we are talking about how I estimate or how I calculate the probability of default, that means that I need to calculate how things might change between today and the time when that default may happen. And that requires a lot of understanding of calculus. Is that a boring subject? It is not. It's a very exciting subject. So I decided to go a little bit further, and I took up a book called The 17 Equations That Changed the World by a gentleman called Ian Stewart. That was my source of information. And again, reading that book from a layman perspective, not from an academic perspective, is very interesting because you understand the human beings that actually brought to our body of knowledge what we know today. What were their circumstances and what brought them to understand and to discover what is very useful today? It's not just these equations in the blackboard that were taught to us when we were in college or university, is how they came to understand that. And the history of calculus is a very amazing story because it happened simultaneously by two different gentlemen. One was based in the islands, it was based in the Great Britain. The other one was based in Germany. Sir Isaac Newton was in Great Britain. Gottfried Wilhelm Leibniz was in Germany. They didn't have communication between themselves at the beginning. They learned about them lastly, and Newton was not very happy about that because he thought that Leibniz was copying and stealing from him his genius, and history has proven him wrong. Interestingly, the two of them came to the same conclusions with a different approach. And what calculus is today is a combination of the legacy of the two of them. But basically what they did is that in order to measure distances and changes, they decided to split these distances into little pieces that were easy to be resolved by the known mathematical problems. And then after all these pieces were resolved, then they assembled them together. Now, how could they do that? And Newton said, I actually built a building over the shoulders of giants, because certainly there were other people before them that brought the basic concepts in. And one of them was Pythagoras. The second of them was Archimedes of Syracuse. The third one was René Descartes. And finally, Pierre de Fermat, which, as you could see, Pierre de Fermat was contemporary to Blaise Pascal and helped him very much to produce what the Pascal triangle is all today. But the interesting part of all these four gentlemen is that they brought the solutions to these little mathematical problems where Newton and Leibniz were dividing the big picture to understand change. So let's see what their contribution was. From one side, Pythagoras discovered the famous Pythagoras theorem, which basically states that the sum of the squares of the hypotenuse, which is the opposite side of the right angle, should be equal to the sum of the squares of the two sides that form the right angle. And he proved that using concepts that come from the Euclidean geometry. So you can see the way as this is proven is geometrical, is graphic. You can see that the square, that is c square in the graphic there, correspond to the four sides of the hypotenuse. So, and that adds basically to the sum of the other two sides. And that is important. So important is that today that when you go into your car and you put your Google Maps or your maps or Waze or any other guidance, you don't realize, but they use triangulation all the time. When they calculate the distance between the place where you are and the place where you want to be, that is basically a triangulation process. That is the application of the Pythagoras theorem in practical life. The second gentleman that provided some contribution to us was Archimedes. Archimedes was a very interesting person. He was born in Syracuse. At the time when he was born, Syracuse was part of the Greek legacy. The Romans were trying to conquer Syracuse, but Archimedes was a very interesting genius in engineering, the engineering of these times. He actually developed the concept of lever, which is leverage. And one of his inventions was linking a claw to a big stick that was taken, or that actually captured the Roman ships when the Romans were approaching Syracuse. And by doing that, it basically put the ship in vertical position. All the sailors fell to the water, and they believed that Syracuse had a kind of monster that was defending them. And that was actually the invention of Archimedes. He was really a genius. And part of the process, what he actually contributed to that is that you may remember the Eureka moment. Well, he discovered the Eureka moment working for his cousin, who was the king of Syracuse, Hieros II, who ordered the manufacturing of a crown in pure gold, but he distrusted the artisan who was crafting it, because he normally cheated and mixed other metals. And he asked Archimedes to detect whether or not there was a fraud in the way as the crown was crafted. So Archimedes basically, he couldn't destroy and melt the crown. So when he was taking a bath, he discovered that when he put his body in the water not being compressible, went out in the same volume of his weight. And that generated his eureka moment, because using that proportion between volume and weight, he actually calculated whether or not there was a fraud in the manufacturing of this crown, and actually there was a fraud. So it's a very interesting reason why what we know today as the Archimedes principle is a result of this analysis and this kind of investigation. Now, why this is relevant? We are going to see that, because when we calculate the distance between the economic capacity of any given individual or company and default, is a matter of that volume gap. I mean, the Archimedes formula is going to be a factor of the calculation of the probability of default. The other important contribution that led to the genius of calculus was the Cartesian plane, which is that came from René Descartes. And basically what the Cartesian plane allow is that all the measures of distances could be put into different points, and these points could be put into a plane, a Cartesian plane. And you can see how in the Cartesian plane we can apply the Pythagoras calculation to calculate the distance between 2 points, because we can create artificial right triangles that will allow us to do that. And the fourth contribution came from Pierre de Fermat. Pierre de Fermat calculated optimization. And optimization basically was the concept of how can you, for example, build a space. You can think about, for example, a bag that you can carry on in the plane. You want to keep the maximum volume there, to have the maximum amount of things, but you have a limited space. How can you do that in an optimal way? And that's exactly what Fermat created, that formula that uses these different points in the curve and the concept of the optimus point that is part of what calculus brings to us nowadays. So with the contribution of these gentlemen, then Newton took all these concepts and decided to look for how to define or how to integrate these little pieces that were, slice and dice in little triangles to calculate the distances of the movement, to the point to calculate the overall space that was, for example, taken by an asteroid or any other kind of object. So, aviation and all what we know today by mobility is actually driven by all the discoveries of Newton. He put together in this slice and dice, we are talking about derivatives, and in putting together all these small points into something unique, then we are talking about the integrals, the integration of what nowadays represent the area of the curves. This is going to be relevant when we go into the estimate of the probability of default. Now, what was Leibniz's legacy? Well, actually, the name calculus comes from Leibniz, not from Newton. And what Leibniz actually contributed beyond Newton is how much new distance we can gain for infinitesimal acceleration. So he basically, beyond the concept of speed that was the forte of Newton, he actually focused on the concept of the gain of additional speed to speed. That is the concept of acceleration. And by the same token, he went into the point to calculate the integral, which is the final space. When you, for example, start driving a car that accelerates every 10 minutes, 10 kilometers per hour, how many kilometers you cover over 1 hour. And that's the kind of calculation that is made thanks to Leibniz. And actually the answer is 50. Now, when you take all that and you try to find a shortcut, then that's where another genius, Sir William Rowan Hamilton, comes from and say, okay, don't worry. Once you get into the Cartesian plane and you put all the points of distances that has a coordinate, an ordinate and a coordinate, so or an abscissa and a coordinate. So what you simply need to do is to calculate the slope of the curve, which is something that comes, and the slope is the angle of the curve, or the way, and you need to also calculate the intercept, which is the point where when the abscissa is 0, then what is the number that corresponds to y in the Cartesian plane, and that is called the intercept. So his equation is very simple. Every curve can be represented by y equal m, which is the slope, multiplied by x, plus b, which is the intercept. So that helps us to calculate probability of default. We will see that in the future. But once you see what is the trend of what happened in the past, this equation is going to help us calculate the probability of default. Now, in order to simplify as well what came after Newton, then a new gentleman comes, and he's Sir John Wallis. He was a British mathematician, also ordained as a clergyman, and he actually created the equation or the formula that allow us to reduce an integral into a derivative and vice versa. How to calculate the integral of any number, or how to calculate the derivative of any number. And Newton actually was a precursor of the digital computing of today, because the way as he expressed all the numbers was based on multiplication of the countries by 10 at a certain power. And you see how, for example, the pi number is the result of this 3 times 10 at the 0 power plus 1 plus 110 at the 1 power, and so on and so forth. This is important because when computers came into mind, with digital computers came into mind, that is the expression that the digital language is using nowadays. Now, if we go back to the games, then here comes Girolamo Cardano. Girolamo Cardano was a very interesting guy, but he had a problem. He was an illegitimate child. He was a physician, he was a medical doctor, and he discovered the virus of typhus and the corresponding remedy. But no medical academy accepted him because he was an illegitimate son. That was his downfall. But he was a genius, and he made a very basic observation, which is, and that answers the question that the Greeks asked, which is how many events may happen in the future from where we are today. And that, taking games, he analyzed the concept of the game of dice. And I don't know if you can see the table, probably is not too big, but he developed the concept of the different combinations. How can you get one? Obviously, in 2 dice, the outcome is 0 because the minimum is 2. But how many times you can get 2? It will be certainly 1. How many times can you get 3? So it will be 2 plus 1 and 1 plus 2. That's 2 times, and so on and so forth. And adding up all the different possibilities, he defined what he called the circuit, and the circuit added up to 32. So that means that what you can calculate, that is for the dice to fall into certain number, for example, number 3, then you will have 2 out of 36, which means is 1/18 of probability that the dice could fall there. That was an outstanding finding. And it came to another interesting concept that still we use when we bet on racing, which is the concept of the odds. When we talk about probabilities, we talk about how many outcomes of the dice could come out of the total circuit, which is 36. But when we talk about odds, we are talking about how many possibilities in my favor will happen and how many possibilities against me may happen. So if I have 2 of 36, I have 34 of 36 against me. And that's a very interesting concept, the concept of odds, because you'll see in many aspects in life, that is something that happens very, very often, which is people tend to use the concept of odds as probability, and there are different concepts. Now, Galileo Galilei comes in. He writes a very small white paper called About the Game of Dice, and he basically challenges the mathematicians to calculate probabilities using the input suggested by Cardano. So in a way, Galileo was the broadcaster of Cardano and made him famous. Otherwise, probably we wouldn't know nothing about Cardano. But that takes us back to our friend, the Chevalier de Marais. Chevalier Marais actually was a gentleman called Antoine Gombeau, French. He was an amateur mathematician and gambler. He didn't have the skills that Pascal had. And at that time, there was something very interesting. There was a priest that was called Marcel Mériens, and that priest became what some people call the Facebook of today. He created the so-called Mériens Salon. He organized discussions among scientists, and he became the individual who actually was the center of the letters that were written at that time from all the mathematicians and geniuses of the time. So he was a kind of clearinghouse for all of them. He received letters from Fermat, and he distributed the letter to Pascal. He received letters from the Chevalier de Marais, and that's exactly what happened. Chevalier Marais asked the question, and the Abbat Mériens said the right person to answer that question is Pascal. But then Pascal came back and said, probably I'm not able to answer that question without help. So the Abbat Mériens decided to send a letter to Pierre de Fermat. And that created a very interesting change in dialogue. And basically getting back into the concept of the question that Pacioli have asked, the problem of the points was reformulated by the Chevalier de Marais in the following way. A team plays ball such that a total of 60 points is required to win the game. And each inning counts 10 points. You know, in a way, you remember that Pacioli was talking about 6. He's talking about 60, but every inning counts like 10 points. The stakes are 24 ducats. By some incident, they cannot finish the game when one side has 50 points and the other 30. And the question is, how should the prize money be divided between the two teams? And here, what the Chevalier Marais had in mind was, well, the idea that Fra Luca Pacioli had was divide the stakes according to the score, 50-30. And look at this. He was focusing on the outcome of the past. He was ignoring what could happen in the future. So according to the formula that Pacioli have given centuries ago, out of the 24 points or coins or whatever you have, 15 should go to the player who got won more and 9 to the other players. Then Cardano, our friend Cardano said, I'm not convinced because there is an error here. And the error is that it could happen that, I mean, again, you are talking about the past, you should go and look about the future. Then Cardano suggests another formula, but he approached that wrong because he said that the one who was in advance should take 6, that is 6 times the outcome of the other. It was like 18 to 3. That was impossible to find. And Tartaglia, which was another mathematician, came into the concept and say, well, Fra Luca has a problem, which is we are talking about a situation where they have advanced to have 5 games won and 3 games won. What about the situation where one of them has won only 1 game? So it will be, according to your decision, that one will take the whole points. And I think that that's not the right approach. And certainly the Chevalier de Marais was of the same opinion. That was not the right approach. So Blaise Pascal comes into play. Interesting gentleman, Pascal. He was born in the 17th century. He was a child prodigy. You'll see a lot of his history. He actually calculated the volume of the cube at that time when he was 7 years old. His father was what is called a tax farmer. A tax farmer was an individual who loaned money to the king in exchange of the right to extract the taxes from the citizens. So obviously, you can see that he could be the precursor of the modern factoring business, because he actually advanced money to the king and bought all the tax revenues that the king was allowed to make. And he became a millionaire until one day the Cardinal Richelieu decided to default on the king debt during the 30 Years' War. So, default in sovereigns is not new. It's something that happened also very often in the past. But then, as I mentioned before, Pascal looked for the help of Fermat, and Fermat came with the following thought. Fermat said, if one player needs to win R more rounds and the other player needs to win S more rounds, then the game will for sure end when one of them will win at the end when R plus S minus 1 additional rounds have happened. And then that means that if the plays are 2, the circuit will be the number resulting to the power of 2 at R plus S minus 1. And that seemed to be a little bit complex for Pascal, drove him to build the Pascal triangle. But before we get into the conclusion that Pascal took, there was another thought that came at the same time for Pascal that also has to do a lot in probabilities. Pascal was debating himself about whether or not it makes sense to believe in God or not believing in God. And in terms of practical outcomes, he said, okay, let's see that you believe in God. If God exists, then you will be eternally happy. If God doesn't exist, nothing happens to you. If you don't believe in God and you behave well, nothing happens to you. But if you don't, and if God exists and you don't behave well, then you are going to be in eternal misery. So you better believe in God. That's the final conclusion that Pascal took just for this analysis that leads to the triangle. Why this is relevant, and this is exactly the rationale of Pascal that, again, is the basis of the science of probability. He said, okay, let's slice and dice the whole process. Let's suppose that when the score was 50-50, I mean, the two parties have won the same amount of games, then we will distribute 12 ducats and 12 ducats. Now, when the other party starts winning the next one, so again, they are 50-50, then in the second game, the winning party wins 6 ducats more. And then in the next one, wins 3 ducats more. So at the end of the day, the distribution is going to be 12 plus 6 plus 3. That is 21 ducats from the one who was winning more points, and 3 for the second one. That was the solution that Pascal gave to the problem of the points raised or questioned by the Chevalier de Marais. And he went beyond that and said, let's suppose that the score was not 50-30, but 50-40. And if it was 50-40, then the winner will get 18 ducats and the loser will get 6 ducats. One of the important rationale that Pascal did here was when you give the money to the pot, when you give the money to the casino, that money belongs to the pot, belongs to the casino, it doesn't belong to you. And therefore, you need to consider that when you are calculating your probabilities of what is going to happen in the future. So there are different alternatives that are going to happen. You can analyze what is the probability of these alternatives to happen. And the way to put that together is this triangle. That triangle is going to explain step by step what could happen according to the number of options that are related to that. And that's where the contribution of Fermat plays an important role, because Fermat places us in the R plus S minus 1, places us in the number of rows where we want to be. And that will define the size of the circuit as defined by Cardano, and will define then what is the denominator of the division to calculate probabilities. And that is important for us to take that into account. So if you go further to analyze the Pascal triangle, we'll see how that behaves. And in general, you find out that the addition of all the numbers in each row is a power of 2. And the interesting part of that is that it will be, each row will be a power of 2, and the power will be the number of the row minus 1. So in the case of the 6th row, we are talking about 2 at the 5th power. And that's the important part, because that is what feeds the algorithms of probability that today you can use when you calculate probability of default. Of course, getting there is going to be a little bit more difficult, because this concept of probability also applies to what we are going to see in our next episode, which is the law of the large numbers. But in general, what we have today and what we learned today from this gentleman is that when we are approaching probability of default, we need to take into account that there is a concept of distance coming in, that concept of distance is an important concept to be taken into account when we calculate what is the probability of default of a certain individual. And that's part of what we need to consider when we are in the process of analyzing what we need to know about probability of default. So having said this, well, I want to thank you. I don't know if is anyone interested in asking any question. If there is any question, we can have some spare time, probably 5 minutes. If not, then I'll be happy to answer all your questions offline. And I thank you very much for participating in this webinar. And I invite you, if you have interest, to learn a little bit the story of what we learned in the book, just to acquire the book in Amazon.com. And again, once this recording is ready, I'll be happy to repost it for all your benefits. So thank you very much and have a wonderful day.